Just in case you thought I forgot, I did not. So here is your last video on graphs. So a lot of this should be a review. Remember our levels of measurement. They are going to come in handy here in just a minute. So first of all, we have a pie chart. Pie chart is a graph that shows the differences in frequencies or percentages among categories of a nominal or an ordinal variable. The categories are displayed as segments of a circle whose pieces add up to 100% of the total frequencies. This is important. A lot of times that's where folks will go wrong when it comes to pie charts, is that their pieces don't add up to 100%, or that they are not representational of the actual percentage. So we also should be careful because sometimes having too many categories with pie charts can be super messy, right? So you can see here, right, we've got the vast majority of this sample is white, and then black is the next largest category. And then these other ones start to get a little bit messy and complicated and hard to tell exactly what's going on up here. So if we reduce some of those categories and we just have white, black, and other, and two or more races, this becomes a lot easier to see, understand, and sort of visually represent the data. So right here, again, we have a pie chart as an example of marital status among U.S. adult women. Again, we want to see that these, each segment of the pie chart is making up the percentage that it should, right? So 56.5 is the largest one. It's more than 50%. So it makes sense that it's like this. We want to see them, right, is this visual representation of data. So this is a great example of when it looks wrong. So what does this even mean? Right? Because we have 63%, 60%, and 70%. This is not how you make a pie chart, right, folks? So I think what they have done here is they asked people, do you back Romney? Do you back Huckabee? Do you back Palin? And I guess 70% said they backed Palin, 60% said they backed Romney, 63% said they backed Huckabee. But this isn't giving us a very clear understanding of what the heck is going on. So it should have been, maybe they should have asked, do you back only Palin? Do you back only Romney? Do you back only Huckabee? And then do you support more than one candidate? Or do you support all candidates? That might have been a better way to get this information in a pie chart. But you can see what they've done here is they've asked this 3 different questions and put all 3 questions into one pie chart, and that doesn't make any sense. The next type of chart and graph we're going to look at is a one variable bar chart. So these are graphs showing the differences in frequencies, percentages, or proportions among categories of a nominal or an ordinal variable. The categories are displayed as rectangles of equal width with their height proportional to the frequency or percentage of the category. So remember, pie chart and bar chart, one variable bar chart, are both only going to be used for nominal or ordinal variables. Neither of those can be used for an interval ratio. So our one variable bar chart, pretty straightforward, and it pretty much is showing us the exact same information that the other that the pie chart was also showing us, but in a different way, right? It allows us to see this in a more comparative way. And so when we're looking at our bar charts, right, we have the variable on the bottom, right, the nominal or ordinal. Those are going to be on our x-axis, which is the bottom axis. And then on our y-axis, we're going to have our numbers, right, our scale, to show what the, how many people, right, on each one it corresponds to. So, we see our never married is somewhere a little bit over 20, but below 30, married all the way up here, somewhere like 55, 56, 57%, widowed down here around 10%, and divorced a little bit over 10%, probably somewhere around 11 or 12%. And we can also display more information if we split it, right? So if we want to know marital status, right, by gender, we can look at the number of folks living alone. A male, right, we color coded as this light lavender color. Females coded as this sort of deep maroon color. And so when we split this, we can have our variable split into gender, right? So, or we could split it into race, or we could split it into some other thing, right? Proletariat or bourgeoisie. Like what social class are you, according to Marx? And when we split it into two, this gives us more information without really cluttering things up. So it allows us to not only compare, right, the number of people living alone to the number of people married to the number of people who are somewhere in a different category, but it also allows us to look at the difference in gender. Right, look at this giant gap here between males and females who are married, right, and the number of women who live alone, and the number of women who are other somewhere in there. So, right, this tells us even more information. Again, right, a sort of review of your X and Y axis. So bar charts and bar tables are going to have an X axis and a Y axis. The X axis, right, is horizontal. These are going to be like your columns, right, your male, your female, and your independent variable. It's also going to be, right, the ones that are typically not numerical. So then our y-axis, right, are up and down, not back and forth, up and down. Our y-axis is vertical. It is also, this is going to have the information on the rows, and this is going to be the dependent variable. So if we were making a bar chart and we were looking at gender and the labor force, on our x-axis over here, we're going to have gender, so male, female, and then percent in the labor force is going to go on this y-axis. So if we look at this chart, which one is the x-axis and which one is the y-axis? Correct, right? Our x-axis is going to be this one down here at the bottom, right? Never married, married, widowed, divorced. And our y-axis is going to be over here with the scale. All right, now if we have a bar graph with two variables, we can show the relationship between 2 or 3 variables if one of them is an interval ratio variable. Again, the interval ratio variable must be on the y-axis, and the x-axis can be ordinal or nominal. So if we are looking at men's income by relationship stage, so I'm going to have their income, right, on the y-axis because that is my interval ratio. Didn't mean to do that. That is my interval ratio variable. And then I'm going to have this nominal variable down here at the bottom, and or right, ordinal. And right, so now I'm going to look at it and I'm going to see, okay, so if someone is a cohabiter, they say that there is a 50-50 chance or probably will marry. These guys make somewhere a little bit under $30,000 a year, right? Cohabitors who are definitely going to get married, right, they make around $35,000 a year. Men who are married, right, and cohabitated before marriage or have been married for fewer than 5 years, right, these men are going to make a little bit over 40,000, and right over here are men who are married and cohabitated before marriage and have been married for over 5 years. They make a little bit over $50,000. So again, you're going to have your nominal or ordinal variables down here on the x-axis, and on the y-axis, you're going to have your interval ratio variable and or your scale frequencies. Again, if we look at this, again, similar thing, we can look at women's ideal and usual hours worked by relationship stage. So our relationship stage is going to be on our x value, right, our x-axis. And you'll see that this has two variables in it, right? We've split it by the usual hours they work and what their ideal hours would be. As you can see, most folks work far above their ideal hours. But this, again, is showing us, I'm so sorry, y'all. Sorry about all the yawning. This is showing us lots of information in one chart in a pretty easy to read and understandable way. If we look at this bar chart, what is wrong with it? Let's start by looking at our x-axis. Not necessarily anything wrong here with our x-axis, right? Because that is a ordinal variable. Days of the week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. But let's look at this y level or y-axis. So they are looking at enthusiasm level. Well, that's not an interval ratio, right? It could be if it was, well, it could be ordinal, right, but not interval ratio, because there is no concrete difference between 0 and 1, 1 and 2, 2 and 3, and so on. If you ask teachers to rate their enthusiasm level for school, the best that's ever going to get is ordinal. So first of all, this is not an interval ratio variable. And also, these aren't even numbers, right? This is going to be the best year ever. These kids aren't so bad. Hang in there for the children. How many days until summer? And monster.com. So this is, right, there's a lot of stuff wrong here. Right, what does this mean by how many days? Like, what, right? This doesn't make any sense. If you're actually looking at it and trying to correlate how it works with actual data, you kind of get it, right? Looking at it, it's funny, whatever. But it doesn't actually make sense when you're looking at it statistically, trying to analyze data. This is not how you make a bar chart. You can also do a stacked bar graph. And so this is going to show the distribution of one variable by another variable. So it's going to be used for two variables. This is going to make more sense when I show you an example. Each column is always going to add up to 100%, and each column has different colors representing the distribution of the second variable. And this makes it really easy to compare behaviors across columns. So again, here is here's an example, which I think will make more sense. So in this study, right, they asked different people what their self-described sexual orientation was, what their gender by gender of sexual partner at last hookup. So at last hookup, folks who were asked, they said, okay, what was the gender of the sexual partners in your last hookup? So the answer is either male, female, male, male, or female, female. Granted, this is binary and whatever. That's another issue. But going with this sort of gender binary that they have for us here, we're looking at what was the gender of the sexual partners at your last hookup, as well as what is your sexual orientation. So for folks whose last hookup was a male and a female partner, we see that the vast majority of them, right, somewhere probably over 90%, stated that their self-described sexual orientation is heterosexual. These are always going to add up, right, to 100. We have a little tiny sliver here for homosexual, a little bit bigger sliver for bisexual, and little sliver for unsure. Next, for everyone who answered that their last hookup involved two men, all of these people who said that, right, they're also now looking at their sexual orientation. So it was a fairly low number of men respondents who said that their last hookup was with two men that identified as heterosexual. Right, the vast majority identify as homosexual, a few as bisexual, and a bit more as unsure. We see a very similar number over here for folks whose last hookup was with two females. Similar amount of unsureness. A lot more of the bisexual category, bit smaller of the homosexual category, and a little bit bigger of the heterosexual category. So these types of bar charts, right? What's happening? Right, these stacked bar graphs, they allow us to compare different variables in different ways. So we're able to see a lot of frequencies and a lot of information in a pretty simple, straightforward manner. Next up, we have our histogram, which is a graph showing the differences in frequencies or percentages among the categories of an interval ratio variable. So remember, a lot of our other charts that we have looked at so far are mainly for nominal and ordinal. You could throw in an interval ratio into some of those bar graphs, but you still needed a nominal or an ordinal variable. These histograms are for interval ratio variables. The categories are displayed as contiguous bars with width proportional to the width of the category and height proportional to the frequency or percentage of that category. So, we are seeing here, we have $0 to $10,000 is your salary, 11 to 21,000 is your salary. So these are going to be categories in which they are the same jump from each one to the next. There is no overlap, it wouldn't make sense if this was 0 to 10 and then this was 10 to 20, because then you've got overlap between these two categories for that number 10. So we've got our interval ratio down here as salary on the x-axis, and then on the y-axis here, we have the number of employees at this company. So again, we'll think about when it comes to X and Y, when we are at a histogram, X-axis and Y-axis, we are still going to want to focus on our dependent and independent variable when it comes to which axis do they go on, instead of just thinking about does the nominal and ordinal one, right? If there's no nominal and ordinal, because you can't do that with a histogram, you're still going to be thinking about your dependent versus independent variable as to which axis you put them on. Next up, we have a frequency polygon. A frequency polygon is a graph that shows the differences in frequencies, percentages, or proportions among categories of an interval ratio or dummy variable. And points on this polygon and this graph are going to represent the frequencies of each category, and those are going to be placed above the midpoint of the category and are joined by a straight line. You can use a frequency polygon with two interval ratio variables, and lines can represent ordinal or nominal variables. So what does this mean? So if I want to know the proportion of women with children under the age of 5 by their age and by their degree, right, their highest education, which is an ordinal variable. So over here, I'm going to have women's age at the bottom, right? 0, 20, 21, 22, 23, 25. And then on this left-hand side, on our y-axis, here we have the proportion with the child under the age of 5. And so remember, proportions are just percentages that haven't been multiplied by 100. So, right, we have 10% of folks here, 20% of folks here, 30% of folks here, 40, 50, 60, so on. And then the colors, right, of the lines and what shape is on their little points is going to be down here correspond to what their degree is. So, right, we can see that women who have less than college, right, that they tend to have children under 5 earlier. For women who have a graduate degree, right, their peak is going to be right around here, which is going to fall in with women with a college degree, and those with graduate degrees are going to be just slightly later. So we see here, right, and as women age, it becomes less and less likely that they have a child under 5, which makes sense because it becomes much more difficult to have children, right, past around the age of, right, your early 40s. So by the time you get to 49, highly unlikely, right, just biologically, that there will be that many women with children under 5, at least biological children under 5. So this is able to show us, right, these interval ratio variables, as well as the ordinal variables of, right, the category. Next up, we have a time series chart. This is a graph that displays changes in a variable at different points in time. It shows time, which is measured in units such as years or months, on the horizontal axis or the x-axis, and the frequencies, right, are percentages or rates, right, are proportions of another variable on the vertical axis, also known as the y-axis. So, right, this is probably what you're used to calling a line graph, right, or a line chart, whatever. So again, we're going to see here that we have our time on the bottom, right, every 4 years here. And then on the left, right, on our y-axis, on the vertical axis over here, we have the percent of folks of first marriages preceded by cohabitation based on the year of marriage. So we see that, right, very few folks who were getting married in 1965 to 1969 were cohabitating before marriage, right, less than 10%. But if you go over here all the way to the most recent data point of 2003 to 2008, we see that over 60% of first marriages are preceded by cohabitation now. Right? Very sharp increase over time, which makes sense with what we know about the world and our society, and sort of loosening the expectations and sort of these strict rules about cohabitation before marriage. So these type of graphs give us the ability to look at how something has changed over time, right? Which is helpful to call them time series charts. We're looking at how the series of time has changed this variable. Next, and finally, we have a statistical map. These can be used to show geographic differences in behavior. Sometimes we also call them cartograms. They can use only one variable other than the geographic area, which is usually used with a dummy variable. And each geographic area is a different color to represent the proportion or percent of people in that area who answered yes to that variable. So, right, you are probably familiar with seeing things like this. So this is a map at the county level, which shows the same-sex couples per 1,000 households by county. So our key down here, this is a terrible screen grab, but our key down here shows us that this light color is between 0 and 4% of household, or 0 to 4 per 1,000 households have same-sex couples in them, and going up and up and up. So these darker colors are going to be counties that have higher numbers of same-sex couples in the county, and the lighter the color, the less likely it is that they have same-sex couples per 1,000 households, right? Pretty handy. We can also look at the state level. If for those of you who have taken 225 with me, this might be familiar to you. And this is a map of felony disenfranchisement rates in 1980 by state. So again, we are looking at the ways in which it is color-coded. This time, it's not done by county, but done by state. Again, we have this key over here that shows us what the colors represent. And it's a good way to sort of visually get a good idea, of this big picture thing, this big picture issue very quickly with a visual aid. Sometimes we distort our statistical maps to represent population size. So in this map, this is showing us the electoral map, college map, and it's showing us how each state is either bigger or smaller based on its share of electoral college votes. Electoral college votes are based on population. And we know, if you've been following politics in the last few years, how important these electoral colleges are. These electoral college votes are. And you probably know that California has a lot, Texas has a lot, Florida has a lot, New York, Pennsylvania, these big Midwestern states up here that everyone is focused on a lot. And you'll see that these states that have smaller populations, Montana, Wyoming, North Dakota, South Dakota, all of those, they are smaller because they have less electoral college votes. So it's kind of wonky to look at this at first when you're not expecting it, but it sort of shows you, this representation of where the biggest weight is, and how that sort of distorts the way that, we would normally think about this. Here's another example, just because this one, I don't know, there's something about the shape of this that makes me chuckle a little bit. But again, this is still from that felony disenfranchisement article, if you took me for 225, that you've already read. 6 million lost votes, blah, 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 is the name of the thing. It does not have blah, blah, blah in the title. Sorry about that. But this is looking again at felony disenfranchisement rates in 2016 by state, and they have distorted these states to sort of show you how unequal it is, and sort of where the heaviest weight falls. As we see, Florida has a lot, which makes sense because these are the darker colors. And so the smaller the state, the smaller the rate of felony disenfranchisement, the smaller the state is going to be in this graph. And the darker the color, the higher the rate of felony disenfranchisement, which means that they are even bigger on the map than they should be. So this sort of helps us look at the ways in which populations are maybe a little bit different. This helps sort of show us the skew in a different way than just looking at color-coded without this sort of distortion does. We can also take this out one step further and look at it on a global scale. So we looked at county level, we looked at state level, and now we're looking at global. And again, we might look for female life expectancy at birth. We have less than 50 in this light yellow, 50 to 59.99 in this darker yellow, orange, and so on and so forth. And we can look at this and sort of get this visual idea of how things are all across the globe. One thing that you should be careful with almost always when it comes to making graphs and charts, whether it's a pie chart, whether it is one of these cartograms, or mapping a statistical map, one thing you want to be aware of and careful of is to not make your colors too similar. So that is one of the problems I have here with this map, global map. It is really hard to tell the difference, at least on my computer screen, probably yours as well, what the difference is between this light yellow and medium yellow. Furthermore, right, looking down here at the 70 to 79 and the 80 to 85, really hard to see the difference, especially when you're zoomed out like this. So, for example, Canada and the US are a different color than Mexico and Central America, but really hard to see unless you get all up in close to that. Similarly, over here with Europe, we have Western Europe being this darker color. Russia and some Eastern Europe is more in this lighter color, but really hard to sort of tell the difference there. So when you are picking your charts, your colors, make sure that you are picking colors that are drastically different from one another, right? This chart is super easy to read because of how vibrant the colors are and how different they are from one another. But if all four of these lines were just shades of pink or shades of blue, all rather close to one another, it would be really, really hard to tell the difference. You get a little bit of help here because of the different point shapes. Right, we have a square and then or a diamond for purple, a square for pink, a triangle for yellow, and like these X's on the cyan color. But again, if we had all of these like the same-ish shade of the same color, it would just make it look a whole lot more sloppy. So make sure when you are doing things like this that your colors are different from one another. Again, you'd have that same issue over here in these stacked bar graphs. You'd have the same issue looking at these side-by-side bar graphs. You would have issues, really big issues here in your pie charts if these were all very similar colors and it was hard to tell the difference. So that is good things to think about when it comes to making a good graph. Make sure that each category is visibly different because, again, these are visual representations of descriptive statistics, right? Of telling you how to easily understand this data and to easily visualize it without having to look at frequency tables. But essentially, right, all of the information that's contained within all of these graphs that we've just looked at are the same type of data that you've been doing in the previous unit. Looking at the frequency tables, right? Looking at percentages, looking at frequencies, things like that, cumulative percents. This is just how to represent descriptive statistics in a visual way. And so if our goal is to make this visually accessible, we want to make sure that we are doing that in a way that is super clear and super straightforward, because otherwise we would just be showing them our frequency tables. All right, that is my little chat about graphs. Let me know if you have any questions. The only one that you will need to know how to do for the homework is the pie chart. But when it comes to the first quiz, everything is fair game. I would encourage you to pay attention to which type of variables you can use for which chart. So I may give you a question like, with an interval ratio variable, which of the following types of graphs and charts would I not be able to use? And so I might say, like a histogram or, a time series chart, a bar graph, with two variables, or a pie chart, right? Well, the pie chart is the only one that you cannot use at all with an interval ratio variable by itself. So questions like that. So think about which ones you can use for which. I might give you questions about what goes on the x-axis and what goes on the y-axis. I might give you questions that ask you what's wrong with this graph. I might ask you on which axis does the dependent variable fall and which axis does the independent variable fall. Words are getting harder and harder to say. So keep a lot of these things in mind, right? Your exams, your quizzes are going to be open note. So take some notes, but you're not really going to have time to go back through and watch all these videos again to find the answers. So make sure that you have taken good notes on these slides and have a pretty good idea about what each type of graph does and what type of variable can be used for these different types of charts and graphs. All right, that is all you have for Unit 1. We finally made it through to the very end. We will be, again, meeting in the lab this upcoming week, right, Gram 202, to start our exploration of SPSS.